Hi guys, we are going to look at Janjang again today. And today we are going to look at Janjang Geometri. I have already discussed what is Janjang. Janjang merupakan jujukan nombor yang mengikut corak tertentu. A progression is a set of numbers that arrange in a logical and predictable pattern. So, today we are going to see what is the pattern of the Janjang geometry or geometric progression. Janjang geometri merupakan suatu jujukan nombor dengan setiap sebutan diperoleh dengan mendarab satu pemalar kepada sebutan sebelumnya. Geometric progression is a mathematical sequence in which every term is obtained by multiplying a constant to the earlier term. Let's see this diagram. In the first box, there's one chip. In the second box, there are two chips. In the third box, there are 4, and in the fourth box, there are 8. The chips in this diagram is increasing by 2 times. Dalam gambar ini, chip-chip tersebut bertambah sebanyak 2 kali ganda. Maka terdapat satu pemalar. Hence, there is a constant. It increases by multiplying 2 each. Therefore, the constant is 2. The R is 2. Setiap penambahan adalah dengan mendarab 2, maka pemalar tersebut ialah 2. R ialah 2. Apakah R? R ialah nisbah sepunya ataupun common ratio. The R is a common ratio. Let's see the example. 1, -3, 9, -27. We will use the second term to divide by the first term, which is -3/1. The third term divide by the second term, which is 9 divided by -3. And the fourth term divided by the third term, which is -27 divided by 9. And all of them are giving you the answer of -3. Therefore, there is a constant. And the R common ratio existed. Therefore, it is a geometric progression. Dalam pengiraan ini, kita dapati bahawa ini merupakan satu pemalar. Maka nisbah sepunya wujud dan jujukan nombor ini merupakan satu janjang geometri. Please look at the second example. By using the same method, we are going to use the second term 1/4 divided by the first term 1/2. The third term 1/8 divided by the second term 1/4. The fourth term 1/16 divided by the third term 1/8. All of them are giving the answer of 1/2. It is a constant. Therefore, the common ratio existed. And these numbers is geometric progressions. Therefore, from these two examples, you can see the main characteristic of geometric progression is there is a common ratio. Next, we are going to see the end term of geometric progression. Let's see the first example. 1, -3, 9, -27. As we found out just now, the R is -3. The first term is A, which is 1. The second term is AR to the power of n. The third term is AR to the power of 2. The fourth term is AR to the power of 3. And what is the 13th term? So by using the formula, the n term is ar to the power of n minus 1. The 13th term will be ar to the power of 12. Where the a is 1, r is negative 3 to the power of 12. The answer is 531,441. You see, it is easier when we use the formula. You will be able to find many terms by using the n-term formula. Next example, 1 over 2, 1 over 4, 1 over 8, 1 over 16, and the r we found is 1 over 2. A is 1 over 2, which is the first term. T2 is ar to the power of 1. T3 is ar to the power of 2. T4 is ar to the power of 3. So, what is T11? Of course, it is ar to the power of 10. And you will be able to get the answer by using the formula. Next, we are going to see the sum of n terms. As I discussed with you earlier, the sum of n terms must be adding the terms from the first term until the n term. Hasil jumlah bagi semua sebutan n merupakan sebutan dari sebutan pertama ke sebutan ke n. There are two formula in Janjang Geometri. Terdapat dua formula dalam Janjang Geometri. The first one is when r is in between negative 1 and 1. Sekiranya r di antara negatif 1 hingga 1, inilah formulanya. This is the formula when the r is in between negative 1 and 1. Let's see the example. 1 over 2, 1 over 4, 1 over 8, 1 over 16. The r is 1 over 2, which is in between negative 1 and 1. Therefore, we use this formula. By using this formula, we do not have to list out the summation of all the terms. Instead of that, we use the formula to find S2, which is 1 over 2, which is the A, times 1 minus R, which is half, to the power of N, which is 2, divided by 1 minus R. So, you will get the answer same as the answer where you listed the terms and added them up. Same thing goes to S3. Instead of adding T1, T2, and T3, we can use the formula of A into 1 minus R to the power of N over 1 minus R. And the answer is the same as how you listed out. Just now we discussed about when R is in between negative 1 and 1. If the R is not in that range, when R is less than negative 1 or R is more than 1, sekiranya R bukan dalam lingkungan negatif 1 hingga 1, tetapi R kurang daripada negatif 1 ataupun R lebih daripada 1, inilah formulanya. The example is 1, negative 3, 9, negative 27, where the R is negative 3. Negative 3 is less than negative 1. Therefore, we use this formula. So how do we use the formula? Instead of listing them out, we may use the formula S2 equals to A, which is 1, times R, which is negative 3, to the power of N, minus 1 over r minus 1. And you will be able to get the answer same as how we listed out. So same thing goes to others. So it is easier to use the summation formula. But don't forget there are two different formulas. One is in between -1 to 1 for r. The other one is when r less than -1 or r more than 1. Next one, we are going to see what is sum to infinity. Sum to infinity is adding the terms from the first term until the infinity term. What is the infinity term? It is very, very big, where it is uncountable, where we denote it as infinity. We normally see S2, S3, S4, S10, S20, but this is S infinity. It means we are going to add from the first term until uncountable term. So, the thing that we will have to take note here is the R. The R here must be in between -1 to 1. Untuk hasil jumlah tak terhingga, R mesti di antara -1 hingga 1. And this is the formula. Ini merupakan formula bagi hasil tambah bagi sebutan tak terhingga. So, what you do is only by substituting A over 1 minus R. And the answer is 1 for this progression. For today, we have already learned 4 formulas. The first one, which is the nth term for geometric progression, which is equivalent to AR to the power of n minus 1, where the R is Tn over Tn minus 1. The second formula that we learned was Sn equals to A into 1 minus R to the power of n over 1 minus R. This is for the R in between -1 and 1. The next formula we learned was Sn equals to A into R to the power of n minus 1 over R minus 1. For this formula, the R must be less than -1 or more than 1. Lastly, there is sum to infinity where it is A over 1 minus R, and the R also must be in between -1 to 1. That's all for today, and we are going to learn about how to solve these problems about geometric progressions and arithmetic progressions in the next video. See you again.